Okay, in this video, we will be taking a look at some two-column proof examples where we have to apply the angle-side theorems. Okay, so let's just start by taking a look at the givens and labeling those on the diagram with tick marks. So our first given says that FH is congruent to GJ. So I'm just going to put some tick marks here. FH, segment FH, and then segment GJ. The second given says that triangle FKJ is isosceles with FK congruent to JK. So right away from this second given, I should recognize that I have two congruent sides in the same triangle, the large triangle, triangle FKJ. So immediately that should tell me that this is going to be a proof where I can use one of the angle side theorems. Okay, so I'd like you to pause the video now, see if you can complete this proof, and then press play to check your answers. So go ahead and pause now. Okay, so check your steps. This is a pretty straightforward proof. Really, the only new part is using the angle side theorem to get a pair of corresponding angles congruent in the two triangles. So if you look at step 4 here, this is the only new thing. We could prove angle J is congruent to angle F because if two sides of a triangle are congruent, then the angles across from those sides are congruent. So really the trickiest part is just being able to recognize when to use the angle side theorems, because a lot of times people don't see it right away. So look for those congruent sides, look for those congruent angles in the same triangle. Okay, so let's try this last example. Okay, in this last example, we are given that angle 3 is congruent to angle 4, so I'm going to put tick marks on those angles. We're given that segment BX is congruent to segment AY, and that BX and AY are perpendicular to segment WZ. And we want to prove that the large triangle, triangle WTZ, is isosceles. So this one may be a little bit more challenging for you to do, but I would like you to take a minute, attempt this proof, get as far as you can based on that given information, and see if you can get to proving that that large triangle is isosceles. You're going to see proofs similar to these very often in this chapter. So pause the video here, try the proof, and then when you're ready, press play to check your answers. Okay, so this proof was a little bit longer, and you did have to prove the two smaller triangles congruent, so there was a review of some theorems from chapter 2 about supplementary angles and angles that are supplementary to congruent angles, also perpendicular meaning right angles. Once you have the two triangles congruent, you had to use angle W and angle Z to prove that the entire triangle WTZ was isosceles. So if I go ahead and highlight those two angles, angle W is congruent to angle Z. Notice that those angles are in the smaller triangles, but they're also angles in the large triangle. So by our new theorem about isosceles triangles, we can prove that triangle WTZ is isosceles because if two angles in a triangle are congruent, then it is isosceles. A lot of times, what people like to do with a proof like this is after proving angle W congruent to angle Z, they then use the angle side theorem to prove that segment TW is congruent to segment TZ. Because if two angles in a triangle are congruent, then the sides across from those angles are congruent. And then once they get the sides, then they prove that triangle WTZ is isosceles, because if two sides in a triangle are congruent, then it is an isosceles triangle. So that's correct. That's another way of doing it. It would just add one additional step to the end of your proof and make it about a 10-step proof instead of this 9-step proof. So either way, regardless, you can use the angle side theorem, or once you get those two angles, you can go straight to using our new reason for proving triangles isosceles. So it's up to you. So definitely look for those congruent angles and congruent sides in the same triangle. They will help you complete proofs from here on out. So hopefully now you have a better idea of angle side theorems.